All right, boys. Yeah, so I'm just going to follow up on the optimization video that I did regarding behavior trees. I had a comment on the last video that pointed me in the direction of using state machines or bit masks to optimize this big spaghetti here. What this spaghetti is doing, as a reminder, is it's just checking all of the balls that are in the behavior tree and checking them against the balls that are in this the AI controller. But I think the commenter rightfully pointed out that this again would have to be replicated to some extent in probably the animation blueprint and the character blueprint, and maybe some more places as well. So it is a bit, yeah, it's a bit spaghetti like, and there's a lot of checks along the way, and it means manually setting up these booleans every time. So when you add a new one into the behavior tree, you have to then go along to all of your subsequent blueprints that use them and set them all up, which I totally understand. So I spent the day yesterday looking into what bit masks are, and there's loads of documentation on them in regards to the broader, computer science world, where people are coding in C languages, but there's almost nothing in regards to them in Unreal, and they were added in some years ago, but I'm not sure they've become very popular. And I don't totally understand them and the mathematics behind them, but what I think I understand is that basically, instead of having lots of separate booleans that are just a 0 or a 1, what you do is you bind the states of all of those booleans into one long integer, so one long number that can then be put together as one long number and then later pulled out as results, which is more efficient in terms of overheads and passing data around in a system, rather than every tick checking dozens and dozens and dozens of these booleans that are all separate, that need separate, presumably from a CPU point of view, separate operations. What you can do is you can just call on one big number, have that sent around, and then all the blueprints do at their end is decode the number. So it's a form of encoding and decoding into one long integer, basically. Okay, so that being said, what I did yesterday is I looked into bit masks and I tried to implement a system into my behavior tree that sidestepped the usual blackboard set of booleans, and instead opted to use one single integer that contained all the variables within it, all the boolean variables anyway. It can't store location data or actor references. It can really only store true and false states. But so I tried to sidestep all of these booleans and just make one integer, and then that integer is just updated by the behavior tree. So my new functions, they can check against the integer for value, and they can add and subtract from that integer as well, different values. Then in the AI controller end, all I'm doing then is checking for which of those states basically has changed, and outputting here the ones that are set to true, and here the ones that are set to false. So basically it's achieving what this mess is doing in quite a simple way. Well, it's not simple under the hood, but the result is much easier. And another advantage is that it all pivots on an enumerator, which is this one. Yeah, so this is the enumerator, and I can add in and take away booleans from it, and it will be replicated across the whole system. So this will take account of it, this will take account of it, and all of the code within the behavior tree will take account of it. So it's much more adaptable in that sense. But before I go into the detail of how I did it, I should start off by saying, for me, this was a bit of a failure, for one major reason with two components, and that reason is debugging. So what happens with Unreal Engine when you try to debug AI, normally what you normally do is you to debug AI, you hit apostrophe, and you can then choose individual units to look at. Now you can see the first thing that happens is when you run the debug UI, the whole game slows down to about 10 frames a second. I'm assuming that's because it's trying to render the integer. And the other thing that happens is the set of, I show the mouse cursor, the set of booleans that you would normally be looking at the most to try and find out what the AI is doing are just all static, because of course all of the variables now are just going through one integer. So you've gotten rid of, by doing this, I've gotten rid of my ability to debug. So I think I could probably write a new version of this, but I find all of this information very, very useful. I'm probably not good enough to write a whole new UI that would be as effective a debugger that called from the integer each time. So anyway, it failed, but I'm going to go into how I did it, because I think there's not enough info out there on bitmasks and how they work, and I think they could be very useful for people when you're sharing large amounts of bool-based data between blueprints in Unreal. So yeah, I'll go over it anyway, and maybe you can learn something about bitmasks, and yeah, who knows. I should probably also say that after this I'm going to go and try and make a system which still uses the old-fashioned Boolean system in behavior trees, but encodes the integer at the AI controller level. That's what I'm going to be working on next. So I'm basically going to come up with a system that hopefully does that. So it wraps all of the booleans from the behavior tree and puts them into an integer, and that integer then gets shared between the other blueprints. That's what I'm going to do next anyway. I'm going to try. So the first thing I did, and the first snag I ran into, is I made an integer as a variable in the blackboard. Now normally within blueprints you have an option here to assign the integer to a bitmasked integer. That's what normally happens, but on a blackboard you don't. You've only got minimal options for doing anything with it, so it has to just stay as a regular integer for now, and the conversion to a bitmask integer has to be done on the fly within each of the services, decorators and tasks on the behavior tree. So it's just something to bear in mind. You can't actually make a bitmask directly in the blackboard. The next thing to do is make your enumerator, and that's pretty simple. You just go to blueprints and enumeration there, and then all that is, it's a list of all of the potential Boolean names that you want. And then at the bottom it says bitmask flags, and that will turn that enumerator into a bitmaskable set. So yeah, that's another thing to do. So you can see here, I'm just replacing, I didn't replace them all in the end, this is just my testing amount. So can see player, engage, roaming, following, hunting, called. Doesn't really matter for the purposes of this what each of those do specifically in their respective blueprints, just that, you know, they could be anything at all. Okay, then what you've got to do is, in the behavior tree you've got to have nodes that basically do three things. One is check the state, so be able to reach into the enumerator or the integer from the enumerator and check if a variable is true or false. The second one is to be able to add a value to the integer, and the last is to be able to take out a value from the integer. So it's basically working the same as sets of bools would do, but instead we're just operating on one integer. Okay, so the first one is the state check, and it works just the same way as a blackboard decorator would do. So you basically check you decide which bool you want to check, and you choose which state it is, set or not set. I've just done it with a tick box. So you choose the boolean you want to check and whether it's on or off to allow access to the node. So functionally it's the same, but all it's doing internally is it's getting the integer, and then it's comparing the variable you want to check, and then it's outputting whether that variable is there or not. And all I've done is just chosen two trees, whether the state is true or false, and just inverted the result to get whether it's true or false that the variable is set or not set. So it's pretty straightforward. There's a couple of things to bear in mind here. To check the variable, all you do is you just pick your enumerator here. So the enumerator that you made a minute ago, which in my case is called wild animal states, allows when it's exposed to when it's editable to the player, I say the player, the designer, it just becomes a checklist, which is handy. So that's one thing to remember, is that you can choose the variable by just choosing the enumerator as the editable variable there. But this is really for this whole process I had to make two custom blueprint functions. Now you don't have to use a function. You could just basically take this code and put it in here. Oh no, I'm going to hang the system again now. Come on, there we go. Yeah, you could just put the code straight in there and have the same result. It's just if you're performing a function across multiple actors all at the same time, multiple times per second, it's probably best practice to put things into a blueprint function, and you save a little bit of overhead doing that, so I'm told. Yeah, but all this is doing is it's turning a regular list, which would be normally numbered 0, 1, 2, 3, 4, 5, into a power of 2 list. So that's all that is really all that's doing it, and that really all is pretty much the heart of a bitmask, as I understand it. I'm not a computer science guy and I'm not a mathematician, but it's turning a list that is linear into a power of 2 list. So each variable becomes, 0, 2, 4, 6, 8, like that, 16, etc, etc. So each variable becomes a power of 2 value. That's all that is doing. And because of that, then it can be compared properly to the bitmasked integer in the system, and it just checks if that value is there, and if it isn't, then you get a false. Okay, that's all that does. Alright, so the next slightly more complex node is the set state task, and what that looks like is it's fairly simple, but what's in here are a couple of interesting points, which is to do with how you add or subtract values from the enumerated, the bitmask integer. So here again, we're just calling the integer. So AI, the controller, get the blackboard, call the integer, and then then we're going to add the new variable to the integer, which, by the way, adding is equivalent to being true. So the way bitmask stuff works is it checks against, how do I explain this? It checks against a full integer where everything is true. So where all the values are true, meaning they're all present, and the ones that aren't present it considers false. So only the true values are contained in your operating integer at any one time, I think. I think that's the way it works. So basically what we're actually doing here is, rather than setting a variable to true or false, we're just adding it to the current existing usable integer. And then later, to derive our true or false statements, we will check that against the full potential integer. So we'll always have a perfect integer, where everything is true and everything is included, and then we'll have another one where only the statements we want to be true are included, and we'll compare the two, and the ones that are missing will be false and the ones that are there will be true. I think that's the way it works. That's how I'm operating on it anyway. So yeah, to add a value, so in other words, if we go back to our behavior tree and we say, we choose our variable engaged set to true. So to add that, if I can even find it, set state, here we go. Yeah, it's just this or. Now don't ask me why in bitwise or is add. Everything is upside down in bitwise world. so to add to a variable to an integer in bitwise, it's an or statement. I don't make the rules. Okay, then it just sets that variable again. So we take it, add to it, and then reset it with a new variable on board. And exactly the opposite is happening here. Now again, don't ask me why, but a subtract is a not and an and. So we take the original integer, and then we do a not and an and then we reset the variable, and that's a subtract from. So yeah, don't ask me why that is the case, but it is. Alright, so finally for the blackboard, I have a in-out set state. So if you watch my previous video, you'll see me raving about a service which allows you to set statements to true or false on the way in and on the way out, and that's just what this does. You can find out why I think that's any good in my other video, which I suppose I'll link down below. Okay, so here I'm using a map to get a whole bunch of variables from the animal states enumerator and assign a true or false statement to them. So you can see here the way it works is I've only done the in states for now, but I probably won't do the out states. But yeah, so the in states, so those variables that are set when we enter the node are an array here. So I can say, okay, I've got roaming, set that to true, but then at the same time I can go like following, set that to true, and I can set as many variables on or off as I like, and it won't touch the others. So yeah, it's just handy to have that functionality where you can set variables in and out on a node. Okay, so the way that's working is this: it just gets the array of states that I've set in here from the map. So we get the map of states, which is it's just the wild animal states variable twin with a set of booleans as the key, right? We get the length. So for each one, this probably should have a -1 next to it. And actually, it's not the first index. You can see where I've basically just given up on this and not refined the bugs. But yeah, so this should probably be a -1. But anyway, I'm not going to pursue this anymore. I'm going to go back to my old system. All it's doing, yes, is it's cycling through the length. It gets the variable. It gets the boolean for each, and if the boolean is true, it goes along and it adds the variable, and if it's false, it removes it. So it's the same as the last one we just looked at. It's just doing it multiple times from a mapped array. So it's pretty straightforward. I guess if you don't know what's happening here, you can just copy it off the screen, but like I said earlier in the video, this probably isn't worth doing. But I suppose the same principles could work in another type of blueprint where maybe this is worth doing. And then yeah, so at the end, all we're doing then is once those variables have been changed, so there's my enum to bitmask custom node again, which just remind you is this. Once it's been changed, we then tell the AI controller, hey, something has changed. Like I said before, once there's a state change, the behavior tree alerts the AI controller, and then what the AI controller does is like I said before, it has this, it loops through a perfect version of the integer, and it checks to see if what is there and what isn't from the current state of the blackboard integer. So it just goes through and it goes, it goes, okay, that's there, that's not there, that's there, and that's not there, etc., etc. And the ones that are there, it gives me a true, and the ones that aren't there, it gives me a false. So that's how you quickly derive true and false statements from the integer, the bitmask integer. Here's my second custom node that I made, and you can see it's very similar to the other one, the enum to bitmask encoder, which just makes a list a power of 2. And then all this is doing is it's decoding and then telling me if that value is there and turning it into a boolean, true or false. So it's the same thing. It's just rather than giving me the exact value as a raw number, the power of 2 number as a raw number, it just gives me a true or false statement. So you could do almost the same by just using this and then turning that into a bool, but yeah, that's just doing that. It's just that check. So is that there? Go through here. No, it isn't. Give me a false. So give me a untrue. Is it here? Yes, it is. Mark that as true. Give me a flow that says true. So yeah, and then it becomes a state machine basically. So these are updated based upon that original enumerator that you made. So whenever you add, so let's say I add like a new bool to that one, what happens is it is then should be instantly replicated throughout the entire system, and that's one big advantage. So you've got none of the ball ache of doing the manual updating of this spaghetti each time. So yeah, like I said, that's pretty much it. But like I said, the next thing I'm going to do now is try and get the encoding decoding going on here at the AI controller. So I'm going to try and take all of the bools that are in operation on the behavior tree and turn them into a bitmask, or a bitmask and a state machine, or one or the other. I don't know, I'll figure it out. Yeah, any feedback would be really welcome. As always, stick it in the comments. Tell me what I'm doing wrong. I'm just on a journey of discovery. So, and like I said, I'm not a mathematician or a computer scientist. I'm just finding my way blindly through this world. Hopefully some of the information here has helped, and maybe you could repurpose some of this bitmask stuff for your own good, if I haven't completely mucked it up. But yeah,